This time we need to solve an exponential, and this is a little bit of a tricky one because there are two different exponential parts of this equation and they have different bases. If they had the same base, it would actually be easier. We could combine the two together if we worked at it a little bit. But here, we do want to use our usual thinking where we say, okay, if I'm solving and my variable's in the exponent, I need to use logs to bring that out of the exponent. But the deal is that we're not going to be able to cancel both the base e and the base 5, so we just need to pick one, and then we'll work from there to deal with what's left over on the other side. So I'm going to choose the natural log, but the truth is that a log base 5 would be fantastic as well, and really any log would work, but if you choose a base e or a base 5, you'll get a little bit cleaner answer because at least part of this will cancel out. So if we take the natural log of both sides of this equation, on the left-hand side, things cancel out perfectly, so we're just left with an x plus 4. A natural log is a base e, so it will cancel out an exponential with a base e. On the right-hand side, I cannot cancel a natural log with an exponential base 5, but I can use a log property. I have a property that says I can grab this power and move it down to the front. Be careful with this. You'll need to throw some parentheses around that 2x minus 1. Because we are going to have to distribute that natural log of 5 through. So make sure that you include some parentheses there. That distribute is going to be my next step, but let me clarify why I'm doing that. What I'm looking at now is I started with variables stuck in the exponent, and I need to get them out of the exponent, so I used a log. Now what I'm looking at is I have a variable stuck in parentheses, so I'm trying to get rid of the parentheses so that I can continue to work towards solving. So the x plus 4 is fine. On the right-hand side, I get a 2x times the natural log of 5 minus the natural log of 5. Now, my x's aren't stuck anywhere, but I do have an x on each side of the equation, so I'm going to choose a side. I think I'm going to move x's to the right-hand side, but either would be fine. So I will subtract x. In fact, let me use my other color for that. So I will subtract an x from both sides. And while I'm at it, what I want is x's on one side and any terms without an x on the other side. So I'm also going to add the natural log of 5 to both sides. And I will get a 4 plus natural log 5 on the left. And on the right, I have a 2x times the natural log of 5 minus an x now. Okay, so we keep improving. We now have x's not trapped in any mess. X's are on one side of the equation. Anything that doesn't have an x in it is moved to the other side of the equation. This is one of those tricky steps. I made you practice solving literal equations at the beginning of the quarter for this purpose. If this was a standard linear equation, which you might not recognize it, but it's basically linear right now. Like if we had 4 plus 2 equals 2x minus x, that would be easy. We would just say 2x minus x is 1x, and we'd be able to continue. But with one of the x's having a coefficient natural log 5, we can't just combine in that way. So what we have to do instead is to factor the x out. So the way we get down to a single x is by factoring. And then our last step will be to divide out all of that stuff. Factoring rewrites this as a product, so if we want to get rid of everything attached to x, we use division. So on the other side, we'll have a 2 natural log 5 minus 1. And I am completely fine with the answer looking just like this. You can try some log properties to simplify, but I don't think it's worth the trouble. I think this is a messy answer, but it's a perfectly correct answer. It doesn't involve any weird fractions and fractions or anything, so I would say leave it just like this. All right, thanks for watching.